And welcome back. Now today you can see on my desk there are at least 2 fingerprint readers, a very good reason for that, and 2 Arduino boards, especially that one at the back. There's a very good reason for that, and we'll be covering all that in this video. I'll give you also a tip about why we need that extra Arduino board at the back and the problems I had in getting this working initially, but now it runs like a dream. Watch this. If I put my finger on this panel here, look at that lock. See? Easy peasy. Okay, let's get started then how this works. And you need a couple of things. Well, you obviously need a fingerprint reader. You need a Windows program. So if you're not running Windows, I don't know what to tell you really. You don't actually need it, but it's a really good Windows test that this thing is actually working. And that's the bit that took me about 3 hours before I could actually get something working. But I'll tell you why. The minutiae of this video is going to be at the end of the video, okay? So we're going to really blast through this, get this thing running, show you how to do it. It's really easy. I'm not really going to change much code at all because Adafruit have done all the hard work. So let's get cracking. Right, the 2 things you need first up is an empty Arduino sketch and a Windows program. So the sketch obviously looks like this. That's just a plain old brand new sketch from the Arduino IDE. Does nothing, but what it does do of course is link your Arduino's serial ports back to your Windows PC. I say Windows in this case because we will be using this Windows program. This is the thing that connects Windows with that device and allows you to do like enrollments of fingerprints and stuff. Now you can do this on the Arduino, but it's a really good idea to get this working in Windows first because you can actually see in this bit up here, look, what the actual fingerprint looks like. Right, now here's your very first caveat, okay? Now pay attention because I tried to get this working with my clone Arduino R3 that I use all the time. So back to the workbench. So this one here, for example, it just looks like a normal, well, a normal clone. My bench is a little bit full, but let's carry on. This is a upside down DDC Arduino, I think it's called, yeah. And it works absolutely normally like a normal Arduino would, except the big changes, of course, they've made them a little bit cheaper because that chip there that my finger's on, that's the USB to serial interface chip. And that's the CH340G, okay, common as anything. Years ago they used to use FTDI chips, except that there was a whole spate of fake ones, and FTDI, out of fit of pique, sent out a new driver that killed them, so people weren't too happy with that, as you can imagine. So they all use CH340Gs. What happens is though, you cannot use this chip, or at least I haven't managed to get it to work with that chip and that Windows program. I had to dig out this one here, this board, which as you can see is, well, I believe it's still a clone actually, but it's much more like the Arduino is. Maybe it was a very, very early clone, you know, from a few years ago, because, well, there's a couple of things that identify it. One, you've got the Arduino actual chip in here. And when I dug this board out, it didn't even have a chip, so I had to put a chip in and put a bootloader on it and everything. But if you got a board like this, that's great. But more importantly, you see that chip there? That is in fact an 80 mega, I can't remember what it is now, something. I'll put it on screen. And that drives the USB to serial interface. And that is what you need when you're doing this program. Now, if you've got a Leonardo or Pro Micro or something that acts as a sort of a USB device, then there's a special program you can use and it will still work. But without that, it's going to be a bit dodgy. So this one here is connected to that board at the back there. So I'm just going to tidy up this workbench so we can see a little bit about what's going on, and we'll come right back and test that program out. Just wanted to let you know that LCSC Electronics, China's leading electronics components distributor, are sponsoring this video. In the heart of Shenzhen, China, they have a 10,000 square metre warehouse with a much larger one under construction, an investment of some 500 million renminbi. With their semi-automatic machinery, they can pick our orders to have it ready in 4 hours and sent via a variety of global shipping options. As an example, for orders to the USA, Europe and Australia, we can get them in just 3 days. Try them now. Right, now each of these fingerprint readers, and these two are in fact subtly different. This is an R307, but I'll put all the links and everything down in the video description so you'll be able to find them all. Now they've all got 6 wires coming out the back. 2 of them you never need, but which 2 is a bit of a hit and miss unless you know the wiring. So I'm going to put the wiring diagrams out the back as well. So you've got plus and minus, that's the red and the black, and then you've got 2 signal ones. On this one it's the white and green, so you see the white and green in there? Yeah, they're the 2 you need. And one's transmit, one's receive, and they go to the corresponding pins on your CH340G Arduino as transmit and receive. If you don't get these the right way around, don't panic. It will just come up and say, I couldn't find the device. I'll show you what happens. But let's see what happens when it actually works, okay? So the first thing on that Arduino board, before you do anything, before you connect any of this up, is to put a blank sketch on there that effectively does nothing but links those serial ports up to the USB port. So let's do that first. Right, so that's your blank sketch, right? I think we've seen enough of that. It's just a blank sketch. Load it up onto the port where your Arduino is connected to, and well, that's it. End of. Right, next step. Right, run the demo program, which will also be linked under my video. There's 2 different named programs, but they actually bring up the same interface, would you believe? So I suspect they're just clones of each other. So on this program, the very first thing you need to do is connect the reader and the program. So let's see how we do that. So when you first load up the program called sydemo.exe, which as I say will be in the GitHub and below my video, a link to, this is what you get. It goes, okay, we've got all this information on here, but what does it all mean? Just so that you don't get worried about this address up here, this actually means the number of fingerprints that we've already stored, and just slightly confusingly, because I've got 2 fingerprint readers of 2 different types, it still knows about them all. Somehow it must write them away to some file at the back. Anyway, the first thing you need to do is open the device. So you need to know the port number to which your Arduino is connected. In this case it's port 7. What I'm going to do first though is try and connect it to a non-working port. So if I say connect to COM8, look how quickly it fails. Now that appeared, you know, almost instantly of clicking it, right? Which means you've definitely got a communication problem. It doesn't mean you've got these 2 wires, the transmit and receive, the wrong way around. If they were the wrong way around, it would think about it for a bit and then come back and say, no, it didn't work. You get the same error, but it takes a while. But if you're connecting to a port which just doesn't work, then it will come up almost instantly. And that's the problem I had with that CH340G. This came up instantly on clicking that open device on the port I knew the Arduino was. So, right, let's clear that error then and try it on the real port now. So it comes up with a little COM selection and we know it's on COM 7. So we'll click that. Very, very quickly it comes up with all the info over here, all right? Which is great, but it means you're connected basically. Now you can adjust down the bottom here the baud rate, the package size and the security level. My advice is don't, all right? Don't fiddle with that until you know what you're doing. Now you may find over in the addresses, and obviously I've got a few here because I've been fiddling about, there may already be 1 or 2 in there, and I think there's always 1 in there because they actually test these devices, would you believe, and it's great. So how do we enroll a new fingerprint? Now this is, as I say, running on Windows, but you can do this on the Arduino later as well. When you know this bit's working, you think, right, the communication works, the storing of the fingerprint on the actual device itself is working, and the matching is working and all that. So once you've got this bit working, you can then abandon Windows and go, right, now I'll do it all on the Arduino using the Adafruit library, okay? Right, so the first thing you want to do is click on preview there so you can see what you're doing. So the image comes up over here and we say enroll. And then it says, well, which address? That's referring to this address over here. Let me get that little pop-up window up. So we change that then to one we haven't used before because I'll register my little finger or something. So we'll say on this device, this is device number 1. So we'll have this as number 3, I think, 0, 1, 2, 3. The higher numbers are for the other fingerprint reader. And then it will say, please put your finger to sensor. It says at the top there, look. And it's flashing. So what I'm going to do is pick this up because it's stuck down my blue tack and put my little pinky on there. So it's taken a picture and it's transferring it, and then it will ask me to do exactly the same thing again, and the 2 have got to be the same. There's my fingerprint. So now I've got to do the same pretty much in the same place. So it's transferring. Now if I didn't put that back in the same place, you'll say, no, it's no good, I can't do that. So we'll see what it says. Oh, success to enrol. Well, if you did get an error at that point, it says, no, I couldn't match the two fingerprints. You just do it again, and be very, very careful to put your finger in pretty much the same place on here, same pressure and everything, and then it'll work. So what we've done is enrolled now my little pinky on number 3 down the bottom there. Okay, so that is it. Now we can prove that works by saying, right, I want to search for a fingerprint. So click search, and it says at the top there, put your finger to the sensor. So I'm going to put, actually not my little one, I'm going to put my first finger on here and see what it does. Didn't find it because I haven't put it on properly. We'll try it again, shall we? There it is, and it says finger ID 11, because that's the one I did yesterday when I was playing about. Just to prove it though, let's do that little pinky finger of mine. There we are, number 3, you see? Now that's pretty good, and it's all very straightforward, or it looks straightforward on this video. As I say, that took a little bit of going yesterday trying to work out why this or the other one wouldn't accept all this. But once you got it working, it just works. It's nice, all right? However, unless you intend putting all your fingerprints on the device, so they're stored on here, remember, unless you intend putting all those fingerprints on that device using this Windows program, which means you're a bit stuck if you need to take some off or add some more, you need to do it via the Arduino program. Okay, so having got this far, you can go phase 1 complete. Let's move on to phase 2 and do everything else now on the Arduino. Let's do that next. Right, this is the code. Now this is Adafruit code, 99.9% untouched, and bear in mind that this no longer uses those first 2 pins. Why? Well, because you want to send out messages from this sketch, do we not? Well, we can't use pins 1 and 2 then. They're reserved exclusively for the sketch that's running. We can't suddenly send fingerprint details up there. So what we're going to do is use software serial. All right, which you may have used before. It allows you to use any 2 pins as a serial port. However, listen, if you've got a Mega 2560 or any other microcontroller with more than 1 serial port, so a UART basically, more than 1, then you don't need to do that. As this sketch does tell you, I think in here somewhere, that if you've got more than 1, here we are, read all this in here, because it says don't use the software serial, use your hardware serial. If you've got one, use it. If you haven't, and if you use an Arduino you won't have a second one, then use it this way. So what we're saying is we're using pins 2 and 3 for the TX and RX, and once again, as I say, if you get them the wrong way round, nothing will happen. But we'll come on to that. And this is it. This is their code. I haven't touched it apart from one tiny little pit down the bottom. Oh yeah, they've included this function in here that isn't actually used. They've just left it in from when you register a fingerprint. So they give you several examples. This one here to read them. What else do they give you? They give you, so they're giving you 1 to read it, 1 to register, 1 to test it like we're doing now, and a couple of others. You can have a look at that in the library that I'll put up there. However, even though I tend to put the libraries that I'm actually using in my demo here up on my GitHub, so that we know that combination works. It could well be that Adafruit updates this library, next week for all I know, because they found a bug or they've improved it in some way. So always check with Adafruit whether or not the library has been updated, but you can always go back to the library I put in my GitHub as a sort of a snapshot of something that was working at the time. We know absolutely it was working. Okay, right, so the only bit I've changed is down here. I've added another output on pin 8. Yes, I know I've put the magic number in because I was just rushing a little bit yesterday to say, look, turn pin 8 on for 1 second. I just put a delay on. Yes, I know that's bad too. Please, I just wanted to get it working. All right, so we're turning pin 8 on for 1 second if there's a match on the fingerprint ID. And so I've not done anything else. We haven't looked at the ID number or anything else. It's just like, yes, there was a match, and by turning pin 8 on, that turns on a MOSFET, which then turns on that lock you saw. We'll just look at that very briefly as well. So what we actually want to look at though is this debug area to see what happens when I put my finger on the sensor now. Okay, so if we just nip back to the workbench for a sec. Now you see this is the second reader. It's blue, not red. Okay, and you can see on the Arduino. This is just the clone one now, standard clone, works absolutely fine. We're using pins 2 and 3, so green in pin 2, white in pin 3, starting from 0, don't forget 0, 1, 2, 3. Okay, and pin 8 here, the blue one, that's the one going into this board. I'll draw out a little tiny circuit for that, but that'll be in the additional bit at the end of the video, because I'm sure you know how to create a MOSFET circuit, but if you don't, watch the end. And what else? Oh yes, the other thing is, of course, I have to run this now on 12 volts, an additional 12 volts here, not just the USB, because this lock requires 12 volts. Now it says on the website 0.45 amps. I found it's actually lower than that, so it's less than 400, and it actually will work at 9 volts. So, but we'll have a look at the locks and all that a little bit later. So what I'm going to do is put my finger on here and keep the lock-in thing. And right, now I'm going to get the code window on here and we'll do a proper experiment. Okay, here we are then. So what I'm going to do first of all is reset this board so we get something coming up in here. In fact, I can't even remember if I'm monitoring. Oh yes, COM15, that's right. So let's reset the board. Let the program start again. Right, there we are. So Adafruit saying waiting for a valid finger. Well, what we do, we use my first finger because that's the one I have registered on this device. So I'm just going to press that down. I realise that I'm probably doing this upside down. I don't know how this is going to be mounted. That way probably. But anyway, I'm doing it upside down because it's just easier to hold. So if I can put my finger on there. There we are. Found an ID with a confidence of 101. Now that's actually quite high. What's slightly disappointing is that it found an ID and then didn't turn the lock on because I've probably knocked something out. So let me fix that and we'll come right back. Right, I'm back. Let's try that again. I'm going to put my finger on this thing. Watch the debug window up there and watch the lock. Where's the lock on? Here we are. Click and back out again. Don't know if you've got a good shot of that. Let's put that front and center. Now you see what happens there is that it did detect my finger eventually. It takes a long time sometimes if you don't put it square. I'm going to try that again, putting it in a slightly better position. There we are, much quicker. Cool, so that works. Yeah, the reason why it didn't, I think I overloaded my little tiny MOSFET. I knew it wasn't really rated for that lock, but I thought, well, it'll do for the demo. Obviously not. Okay, rest in peace, little MOSFET. Right, let's have a look about where we got all this stuff from. Okay, and there will be links down the bottom of the video again and in the GitHub. So if you need to sort of have a real detailed inspection of what it is you're going to get, do so by all means. And remember, these are two different fingerprint readers, but they both work in exactly the same way, and all those details will be on the GitHub and below this video. Okay, let's have a look where I got it from. Right, this is the fingerprint reader that I actually got from Banggood. Now, I can't believe I spent that much money, actually $16.84, so maybe it's gone up just recently, I don't know. But that was the one that Adafruit showed. Very, very, very similar anyway. I think it probably was that one, just in a slightly different orientation. But so I thought, well, I'm going to try that because I never could get my R307 to work. Well, we know the reason now, don't we? There's nothing wrong with the R307 at all. It was the board I was trying it on that didn't work. So that's $16.84. But if you want the R307, it might be available on Banggood. If it is, I'll put a link in. But otherwise, you can get it from AliExpress. And as I say, it's $11.99, which is much more reasonable. That's about, what, 9 quid, something like that. The other one was 13, by the way. So this one here, that's £13. And from Banggood, I took that little lock. There it is. That was only $4. So what's that? 3 quid? Something like that. Let's check with you know who. Alexa, how much is $4 in British pounds?
$4 is £3.15.
£3.15, which I thought for the purposes of this demo and perhaps putting it onto one of my locks just to prove it all works would be pretty good value. But you can get much, much stronger ones than this. And I'll let you just hunt around for whatever it is you need for that. Right, quick recap then. So to test this out with that Windows program, you're going to need a board like this one here. No, like that one there. Let's get it right. With not a CH340G serial USB interface. Okay. So Incidentally, if anybody does manage to get it working with a CH340G or an FTDI, that's great. You can tell me about it. But you do need a board like that. So genuine Arduino would work, or one of these older clones would work. If you want to skip that Windows fingerprint recognition thing and go straight to the Arduino sketch, you can do that. Of course, if this doesn't work, you're sort of working a bit blind, really, isn't it? You don't know that things are working yet, which is why I recommend going down the Windows route first. That little demo program, very useful. What else? Yeah, two different types of fingerprint reader, but these are almost identical. Details will be after this main bit of the video. And this little circuit here to switch this on, I'll tell you about that later as well. If you know how to do that bit already, though, I'm not going to tell you about it now. And that's about it, really. I'll put some data sheets and a user manual, especially for the R307. Is that the R307? Whichever the R307 is, there's an actual user manual for it, so you can actually write your own library if you wanted to, or just do a few little bits. But anyway, there's a whole user manual for that, and there's a more generic user manual for the R30X series. Okay, now this one, it doesn't say exactly what model this is, but well, we know it works. That's the one that the Adafruit library and indeed article, which I'll also link to, shows you how to use. Right, that's it then. Pretty good. Quick and short and sharp. If you want the details, how all this hangs together and colour codings and all that, hang around. Otherwise, skip to the end, because there might be some more stuff right at the very end of the video. Right, in the meantime, see you next time. Right, you're still here. Good. Right, let's go into a bit more detail about this then. So first of all, when you get these fingerprint modules, they come with 5 wires, as you can see here. No, I tell a lie, 6 wires, and usually they're colour-coded, but they might not be. They might be all red if you don't get exactly the same one, but it doesn't matter. The Adafruit article does tell you how to count from left to right, so which one's which. However, they're not the same depending on which module we've got. Now, this is the R307, and the colour coding for this is different to the colour coding for that one. Okay, so you do have to just be aware a little bit of that. Right, now what I did, these wires are quite thin, so what I did is put a bit of heat shrink, little tiny bits of heat shrink, as you can see, if only the camera would focus properly. And then what I did is solder them onto a header, this white header here, 6-pin header, and then use some hot glue just to hold everything in place, because you just know that all the fiddling about and moving of stuff and unplugging, it's going to snap those wires as soon as you look at them. So a little bit of hot glue keeps it all nice and firm. Okay, now you only use 4 of these wires. The other 2 are just left blank. The spec sheet does say on this one it should be 3.3 volts out of one and a touch signal out of the other. I couldn't get that to work though, but I haven't really spent enough time to really dig down deep into that. So just ignore those for now if that's what you want. You can always have the code tell you when it's found a match and everything. So what else can I tell you about this one over here? Right, this is slightly different orientation, as you can see. Same coloured wires but in different positions. So the power, for example, is in the middle here, okay, not at the end. So I'll put this up. This is the Adafruit version. I say the Adafruit version. I suppose I should show you what Adafruit's actual device looks like. So this is Adafruit's one. As you can see, it looks identical to the one we've bought from Banggood. Well, as far as I can tell, it's identical. But it is $49.95. Quite a jump in price, isn't it? And it's out of stock. So even if you did want it, you're out of luck at the moment. But you can put your name in and get it sent to you. Now, I did say that if you connected the TX and RX wires the wrong way round, so on this board, let me bring it into shot, these 2 here, it wouldn't recognise it, even though you know it's on the right port. So let me swap these round so we have green and white instead of white and green, and I'll show you what happens. Right, so they're swapped round now, so the TX has gone to the wrong port, and but we know it's still on COM7 though, we know the actual board is there, so let's see what happens when we try and connect up. Right, it's thinking about it. Spending a little time thinking about it. It obviously knows something is at the end of those wires. Then it says open device fail, blah 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 blah. So that's the trick to remember. If this demo program thinks about things for a while and goes, there's something there, but I'm not getting the response I expect, and I've tried a few times, which is exactly probably what it is doing, then you know that you've got on the right port, but chances are your wires are the wrong way around. So let's clear that error and switch these wires back again. Right, back they are. So now we're going to say open device, and almost instantly it comes back with all this information here about, yep, it's all done, and baud rate and everything else, and the addresses that it knows about. So there you are. That's a little hint for you. Now, I've not done anything with these buttons down here. I don't even know what they do, to be quite honest. I can imagine, but I have not tested. The thing that we wanted to prove with this Windows program is that, one, we could enroll things using this button here. Don't forget to put the preview on when you enroll. And then you can search for something afterwards. This preview button here, by the way, doesn't seem to do a lot. I don't know what it does. In fact, it never seems to come up when we do a match, or a search, I should say, not a match. I don't know what match does. The template database, that's where all these are stored, so you can actually clear down the device. So let's clear it down now, so that this unit here has no knowledge of any fingerprints whatsoever. Oh, it's come up with a little prompt saying, do you really want to clear all user? Yes, I do. And there we are. See, this has now become empty. So let's match, or let's enroll somebody again now. So it's asking which address we want, address as in which, index. So first one is 0 because we haven't got any there, so 0 it is. And now it says at the top there, look, put your finger on the sensor so we can enroll you. So, as I say, try and be consistent when you do this. A bit difficult over the camera, but let's do my best. So it's done the image. You can take your finger off as soon as it says that. If you smudge the image while you're doing it, so that image there you're seeing now isn't good enough, it will come back and tell you, saying, no, it was too messy, try again. Now it's saying, though, confirm that image, so I'm going to put my finger on again. And take my finger off because it says it's transferring it. Hopefully it will match. Hey. Now what happens if it doesn't match? What happens if the second time you do it, it doesn't work properly? Well, let's have a look at that. We're going to enroll again, and this will be number 1 now. So I'm going to put a different finger on it, that one there, and now it says put the finger on again. Now I'm going to put my thumb on this time, so obviously it won't match it. It's transferring the image, and the error message you see is combined character error. Yeah, so what it's saying is when it tries to match the two images together, it goes, no, this wasn't the same picture, or you put a different part of your finger on or something like that. Okay, so that's what you will get. Easy enough to sort out though, isn't it? Right, here's the circuit then for that MOSFET driver, for that lock. Now remember, it's running from 12 volts, okay? So you can take it, if you plug in a V in, like I did for the demo purposes, of 12 volts into that Arduino, you can then take this power from V in. However, I should point out that during that demo, I noticed the Arduino's voltage regulator was running pretty hot, actually. So I'd probably run this from a separate PSU. That 12 volt one would be fine, but separately into here. So it only goes here, doesn't join to anything else, but the grounds do have to join up together. So you have to connect the ground from that power supply to the Arduino so the current can flow. Now, the MOSFET you use should be a TTL level, that is 5 volt gate type, and we've been through this many times before. So I used here in my demo, what was it? It was an IRL 3705. So that's a TTL level gate, 5 volts. Otherwise, why TTL level? Because otherwise the Arduino, which can only deliver 5 volts, and it's not a real 5 volts, it's 4.8 by the time it comes out of the pin, won't turn this transistor on fully. And if it doesn't turn it on fully, dropping half an amp or more at 12 volts, it's going to get pretty hot. By turning this on fully, because the 4.8 volts is enough to turn this on so that the resistance between these two pins is something like 0.01 of an ohm, means this doesn't get hot at all. That's the whole point about MOSFETs, using them as switches. Okay, that's fine. Now you can find any other MOSFET TTL that will drive that sort of current. Make sure it is current rated, otherwise you'll end up like what I did, and blow up that little tiny 2N7000. Now, some people say you don't need a gate, or you don't need a gate resistor here because this doesn't really take any current. It's all voltage operated, and that is true. The amount of current flowing through the gate is, nanoamps, picoamps, I don't know, it's tiny. But if this fails, as in that 2N7000 that suddenly failed, this resistor is going to prevent the Arduino trying to chuck all the current it can down here and blow up your Arduino at the same time. So this is like a safety net for your Arduino, and I'd say about 150 ohms is good, because the Arduino can pump probably up to about 40 milliamps through that, and it won't blow up. So you might blow this up, but you won't blow up your Arduino. And this is a 10k down to ground. Now, if you're putting this pin into pin 8 directly and never anywhere else, you don't really need this. But if you don't and have it just floating about, then this can start turning on just with you touching it, frankly, because MOSFETs are pretty sensitive. By putting a 10k down to ground here, that 10k will make sure this turns off until there's a real voltage on there. So there we are. That's it. Pretty simple, isn't it? Good luck with that one. Right, that just about brings us to the end of the full video now. But if you go out buying any old fingerprint reader, make sure you do have a data sheet that goes with it, because the pinouts, the wiring on this one is different to the Adafruit. And if you don't know what all these wires and colours mean, then you're sort of guessing really, and you'll only end up frustrated. So there we are. I think that's pretty good. I'm going to think about where I can put this in. I'd like to build it into something just to prove that it all works, just a simple drawer or something. Anyway, that's for me to think about, and if you've got any comments about this entire video, please do leave them down below. There'll be links, affiliate and other ones in the links below, and more likely in my GitHub, because it's easier for people to track links there. Yeah, that's it. Enjoy, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.